Hey everyone, in this video we're going to learn how to solve linear quadratic systems of equations graphically. This is essentially great practice in graphing lines and parabolas in the form of a system of equations that we have to come up with the solutions of. Our directions for each example are going to be solve each of the following systems graphically. And the first system, y equals x squared plus 2x minus 8, and y equals x minus 6. We'll start with the quadratic function. So we want to find as much critical information as we can. So we'll start with the y-intercept. So that's going to be the point 0. If we substitute 0 into the function, we have 0 plus 0 minus 8. So 0, negative 8. Then we want to find the vertex. So we'll start by finding the axis of symmetry. So that's x equals negative b, so negative 2. Over 2a, so that's negative 2 over 2, which is negative 1. So the vertex is going to be the point negative 1, comma. So we'd have positive 1, minus 2 is negative 1, minus 8 is negative 9. And then we need our x-intercepts. And that we have to do a bit of work for. So x squared plus 2x minus 8 equals 0. We can factor this, x minus 4 times x plus 2. Nope, got to switch those signs. I want to add to positive 2, not negative 2, so x plus 4 times x minus 2 equals 0. So either x plus 4 equals 0, or x minus 2 equals 0. So either x equals negative 4 or x equals 2. So our x-intercepts are negative 4, 0, 2, 0. So let's graph the parabolic curve. So 0, negative 8, negative 1, negative 9, 2, 0, negative 4, 0. We like to graph parabolic curves with at least 5 points. So the axis of symmetry is x equals negative 1. So the y-intercept's 1 to the right of the axis of symmetry, so we'll go 1 to the left. Now because we do have a system of equations here, I will fill in a few more points. So if you notice, we don't have a point at x equals 1. So if we plug that in, we'd have 1 squared, which is 1, plus 2, which is 3, minus 8 is negative 5. Negative 1, 2, 3, 4, 5. That's 2 to the right of the axis of symmetry, so we'll go 2 to the left, and we also have a point at negative 5. And the reason I'm doing that is the more points that we have, the more accurate our graph is, the easier it's going to be to find the points of intersection. So we will graph the parabolic curve and label that as y equals x squared plus 2x minus 8. And then we have y equals x minus 6, which is in slope-intercept form. So the slope is 1, and the y-intercept is the point 0, negative 6. So 0, negative 2, 3, 4, 5, 6. A slope of 1. Now I'm going to use the line tool. It makes my life a little easier. I need arrows on that line. So there we have the line y equals x minus 6. Let's get rid of this extra line. Okay, so we're looking for the points of intersection. So they intersect 1, 2 at 2 points. So our solutions, well, 1 point of intersection is negative 2, negative 8. And the other point of intersection is at 1, negative 5. So by finding that extra point, it actually wound up being the point of intersection, so it was worth the time to find. Make sure you label both the parabolic curve and the line Whenever we have multiple graphs on the same set of axes, it's important to label them so we can distinguish one from the other. Our next example, y equals negative x squared minus 6x minus 9, and y equals 4. We'll start with the parabolic curve again. So starting with the y-intercept. So that's the point 0, comma, we have 0, minus 9, so 0, negative 9. Next up, we'll find the axis of symmetry, so x equals the negation of b, so negative 6 over 2a. So that's 6 over negative 2, which is x equals negative 3. So our vertex is the point negative 3. So this one I'm going to plug in. So the negation of negative 3 squared minus 6 times negative 3 minus 9, that's equal to the y value. So we have negative 9 plus 18 minus 9 equals y. So that's 0 equals y. So negative 3, 0. Next, we want to find the x-intercept. So negative x squared minus 6x minus 9 equals 0. Now I'm going to take a second. If the vertex has a y value of 0, that will be an x-intercept. And it should be our only x-intercept. So I'm going to go through this process more as confirmation that the x-intercept is negative 3, 0, more than finding it on its own. So we can factor out negative 1, so x squared plus 6x plus 9 equals 0. So we'd have the negation of x plus 3 times x plus 3 equals 0. So we have either negative 1 equals 0, x plus 3 equals 0, or x plus 3 equals 0. Negative 1 doesn't equal 0. And here we'd have x equals negative 3, or x equals negative 3. So we did confirm that there is one x-intercept. And again, we should remember, when the vertex is the x-intercept, there's only one point. So plotting, we have negative 3, 0, and then we have 0, negative 9. Now that's 3 to the right of the axis of symmetry, so 3 to the left, we'd have negative 6, negative 9. Now we need more points for accuracy, so we'll start by plugging in negative 1. So if we plug in negative 1, we'd have positive 1, but times negative 1, so we'd have negative 1, and then plus 6, which is 5, minus 9 is negative 4. 1, 2, 3, 4. That's 2 to the right of the axis of symmetry, so we'll go 2 to the left. We'll have the point negative 5, negative 4. Next, we'll plug in negative 2. So negative 2 squared is 4, positive 4, times negative 1 is negative 4. And then we have negative 6 times negative 2 is 12. So negative 4 plus 12 is 8. Minus 9 is negative 1. That's 1 to the right of the axis of symmetry, so we'll go 1 to the left. Now we didn't need that level of accuracy. We needed at least 5 points. But with the system of equations, the more accurate, the better chance that we've defined one of the points of intersection. So that's y equals negative x squared minus 6x minus 9. And graphing y equals 4, that's a horizontal line at y equals 4. So again, I'll use the line tool, 1, 2, 3, 4. So that's y equals 4. Now the horizontal line and the parabolic curve do not intersect. So what does that mean about the system of equations? That means that there is no solution. There's no point of intersection between the two. On to our next example. Our system of equations is y equals negative x squared plus 4x plus 5, and y equals 5 minus x. We'll start with the parabolic curve. So we start with the y-intercept. which is the point 0. So we'd have 0 plus 5. So 0, 5. Axis of symmetry, so x equals negative b, so negative 4, over 2a, which is negative 1. So that's going to be negative 4 over negative 2, which is x equals 2. So our vertex is going to be the point 2 comma 2 squared is 4, times negative 1 is negative 4, and then 4 times 2 is 8, so negative 4 plus 8 is positive 4, plus 5 is 9, so 2 comma 9, and then we need our x-intercepts. So we need to set negative x squared plus 4x plus 5 equal to 0. So I factored out negative 1 in the previous example. So in this example, if we moved everything to the right side, we'd have 0 equals x squared minus 4x minus 5. So I'll switch the equal 0 back to the right side, but factor. So we have x minus 5 times x plus 1 as our factors. So that means either x minus 5 equals 0 or x plus 1 equals 0. So either x equals 5 or x equals negative 1. So we have 5 comma 0, negative 1 comma 0 as our x-intercepts. So let's plot our points. So 0, 5, 1, 2, 3, 4, 5. There's our y-intercept. 2, 9. 2, 9. There's our vertex. Negative 1, 0. And 1, 2, 3, 4, 5, 0. The y-intercept is 2 to the left of the axes of symmetry, so we'll go 2 to the right. So that's going to be the point 4, comma 5. And let's just fill in, let's plug in x equals 1. So x equals 1, we'd have 1 squared, which is 1, times negative 1 is negative 1. 4 times 1 is 4, so negative 1 plus 4 is 3, plus 5 is 8. That's 1 to the left of the axes of symmetry, so 1 to the right would be 3 comma 8. So we can, well, let's try to redo that. It can come out like I wanted. So there we have our parabolic curve. So we'll label that y equals negative x squared plus 4x plus 5. Now we'll graph y equals 5 minus x. So the slope there is negative 1, and the y-intercept is 0, 5. So 0, 5. That was also the y-intercept of the parabolic curve. And then we got a slope of negative 1. So I'll connect those with my line tool. And we'll label that y equals 5 minus x. So our points of intersection are here and here. So our solutions are the points 0, 5, which is the y-intercept, and then we have negative 5, 0, which is the x-intercept of both curves. Okay, so this is great practice running through all the information we need to find for the parabolic curve and also graphing our linear functions. Next up, we have y equals x squared minus 4 and y equals negative 4. We'll start with the parabolic curve. So the y-intercept is the point 0, negative 4. 0 squared is 0, minus 4 is negative 4. The axis of symmetry is x equals negative b. Since there's no x term, b is 0 over 2 times 1. So that's x equals 0, which means the vertex is the point 0, negative 4 as well. So the y-intercept and the vertex are the same point. Then we need to find our x-intercepts. So x squared minus 4 equals 0. So we have x minus 2 times x plus 2 as our factors. So either x minus 2 equals 0. That's a weird looking 0. Or x plus 2 equals 0. So we have either x equals 2 or x equals negative 2. So we have 2, 0, negative 2, 0. So we'll plot the 3 points that we have. So 0, negative 4, negative 2, 0, and 2, 0. Now I'll plug in positive 1. So 1 squared is 1, minus 4 is negative 3. That's 1 to the right of the axes of symmetry, so we'll go 1 to the left, so negative 1, negative 3. Now we have 5 points, hopefully that's enough. So that's y equals x squared minus 4. And then we have y equals negative 4, which is a horizontal line at negative 4. So that's y equals negative 4. So they intersect right there at only 1 point. So we have only 1 point of intersection, which is the point 0, negative 4. Okay, so briefly, let's just run through the last cases that we've seen. We've seen a quadratic and a linear function intersect in 2 points. We've seen them not intersect at all, and we've seen them intersect at 1 point. Okay, so those are the 3 different possibilities that we can get when we're solving a system of linear quadratic functions. In this case, we're solving them graphically. So let's look at one more example. Y equals x squared minus 4x plus 3, and y minus 4 equals 2 times the quantity x minus 3. So again, we'll start with the parabola. So the y-intercept is the point 0, 3. 0 minus 0 plus 3. Our axes of symmetry is x equals negative b, which is negative 4, over 2a. So that's positive 4 over 2. So x equals 2. So our vertex is the point 2, comma, 4 minus 8 is negative 4, plus 3 is negative 1. Then we need to find the x-intercepts. So we have x squared minus 4x plus 3 equals 0. So we have x minus 3 times x minus 1 as our 2 factors. So either x minus 3 equals 0 or x minus 1 equals 0. So either x equals 3 or x equals 1. So we have 3, 0 and 1, 0 as our x-intercepts. So let's plot all our points. So 0, 3, that's the y-intercept. 2, negative 1 is the vertex. 1, 0 and 3, 0 are the x-intercepts. The y-intercept is 2 to the left of the axis of symmetry, so we'll go 2 to the right. So we have the point 4, 3 on our curve as well. And let's get one more point for accuracy, so let's plug in negative 1. So we'd have negative 1 squared, which is positive 1. Negative 4 times negative 1 is positive 4, so 1 plus 4 is 5. Plus 3 is 8, so negative 1, 8. And by symmetry, so that's 3 to the left of the axis of symmetry, we'll go 3 to the right. So 3, 4, 5, 8 is also on our curve. Okay, so there we have y equals x squared minus 4x plus 3. And then we have y minus 4 equals 2 times the quantity x minus 3, which is in point slope form. So the slope is 2, and the point on that line is 3, 4. So we'll plot the point 3, 1, 2, 3, 4, a slope of 2. And we'll use the line tool to connect our points. So that's the line y minus 4 equals 2 times x minus 3. So they intersect at 2 points, here and here. So our solutions, that first point is 1, 0, and the second point is 5, 8. So it's a good thing we extended the graph of the parabolic curve a little bit so that we found that point of intersection 5, 8. If we had stopped at those first 5 points, we would have had to go back to the parabolic curve and find more points on our graph so that we would get that point of intersection. Right? If you stop the arrows there, don't just give me the one point of intersection, continue the graph of the parabolic curve. So there are the two solutions. So do as many of these as you can because it's great practice graphing our parabolic curves in standard form, as was the case in all of our examples here, and graphing lines. And then we also get to go through the different cases that can happen. And just to recap that, a line and a parabola can intersect at 2 points, they can intersect at 1 point, or they can never intersect. So with that, go do your practice and then head into the next video, which is solving these systems algebraically. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.